Yeah, my
be
question
quiet.
was related to this.
The next thing we're going to talk about is how to name a polynomial using the degree of the polynomial, and also by its numbers of terms. Let's say we have a polynomial that's just 6. That has a degree of 0 because if you put a variable on it, the variable would have to have a degree of 0 to keep it at a 1. So we call it a degree of 0 because that is your variable's degree. And in order to name that using that degree, anytime you have a 0, that will be called a constant. Moving down, let's say we have a polynomial that has a degree of 1. The reason this has a degree of 1 is because the variable's exponent, the highest exponent, is 1. When you have a degree of 1, that is called linear. Moving down, now we have a polynomial that has a degree of 2. You always look at the variable who has the highest degree. When you have a polynomial that has a degree of 2, you call that quadratic. Moving on, you have a polynomial to a degree of 3. Again, you look at the variable's degree. It is the highest. It is a 3. We call that a cubic. Moving on, when you have a variable with a degree of 4, that is your highest degree, therefore it is your degree, we call that a quartic. These are how to name using the degree. You also need to be able to name a polynomial using the number of terms. You can notice that the polynomial of 6 simply has one term. There's one thing. We call that a monomial. Moving down, the next polynomial has 2 terms. 5x is the first, positive 9 is the second. When it has 2 terms, we call that a binomial, just like a bicycle has 2 wheels. When it has 1, 2, 3 terms, we call that a trinomial, just like a tricycle has 3 wheels. Now moving down, you can see this one only has 1 term. It's the whole thing. There's no adding and subtracting. That's still going to be referenced up here just like we did before. 1 term is a monomial. At the bottom, we can count one more time. There's 1, 2, 3 terms. They're separated by addition and subtraction. When we have 3 terms, we call that a trinomial. We'll apply these in the next problems.